on trig graphs, and the most important thing you guys see is when you're graphing a trig graph. This is the only time that we need to be in radian mode, okay? All the other times our calculator should be in degrees. So change your mode right now to radian. You do that by going to this, right? Gotta go to our mode key, okay? And make sure that radian is highlighted. So hit enter on that, and then you should be good to go. All right. Okay, so a couple things when we look at a sine or cosine curve, just to talk about what things mean in there. Right, so here's our general form. The A in front, or whatever the number is in front, stands for the amplitude. Okay, and what we do for the amplitude, look at that number and make sure you always make it positive. So even if there's a negative number out there, it's still going to be the positive version. Because amplitude is looking at the distance. If we graph our sine or cosine curve and we cut it in the middle, it's the distance up or distance down. That's why it's always positive, because it's a big distance. We kind of looked at this a little bit today, right, in one of your questions. The b value is going to be the number that comes before the x, or before the variable. That's going to be the frequency. Right. The frequency is going to be how many curves you see between 0 and 2 pi. I think I have the definition on the other side. Oh yeah, here, I'll go through the definition in a second. Does anybody know what the C represents? This kind of
horizontal shift.
Nice, horizontal shift. Right. And what way would it go if it's a minus? Close.
Right.
Opposite, yeah. So a minus really means we're going to go to the right. Okay. A plus means you're going to go to the left. Wow. It's just opposite signs. But the ending part, the one on the back, does anybody know what that means? Vertical shift. Right, and this one's nice. If it's positive, it goes up. If it's negative, it goes down. Okay. It's just kind of what everything means in there. Some things about sine and cosine curves, real quick. Cosine curve usually starts at the amplitude, and a sine curve usually starts at 0. And when you look at like a basic sine curve start at 0, they go up, down, and around. That's like one full sine curve. And a cosine curve kind of looks like a horseshoe. So full cosine curve starts at whatever the amplitude is, or 1 if it's general, and it goes down and back up. Okay, so this is a cos. It's kind of how we tell the difference between where they start. Okay. So sometimes you guys are going to get real easy questions, right? Just talking about like what the amplitude is. So here, the amplitude of the graph of this equation. You can just look at what's the number before the sine or cosine. Yeah, good, perfect, got it. Okay. Now other times, right, it's going to be a little bit tougher. For example, like number 2. Okay. Anybody recognize something kind of weird in this graph? It's shifted. Yeah, it's not starting at a nice value anymore. So it's moved up. So imagine if you guys cut this, right through the middle, right? Go ahead and draw a nice line right down the middle. Okay. So we cut this. Oh. You're the other way. Okay. What we want to do is find the amplitude and figure out what's going to be the distance. What do you guys think the amplitude is here? 2, yeah. Good job. There's 2 between. Okay. So we just got to be careful that we're not just looking at the first number and picking the height. Because it's not fixed here. It's because the whole thing was moved. So the amplitude is always the distance between the curves in the middle. Good. Okay. All right. I put this one in just because sometimes with like shifts it's a little bit tricky. All right. They want to know, very similar to this one. Okay. Something happened in this problem that was moved some way. They want to know what the maximum value is going to be here. And a lovely little equation. Right, how'd you get 4? Great. Why did you add 1? What was this if you would see addition at the end? What does that mean you're doing? Good job, Miss Rita. Right. Right, so vertical shift up 1 unit. So imagine your amplitude, right, was originally 3. Okay, but it took that and it moved it up 1 unit. So now the maximum value, the highest point, is going to be 4. Good job, Rita. That's perfect. Good explanation, too. Good explanation, the whole thing. That's good. How do you guys feel about amplitude and like recognizing amplitude? That's easy? Okay. Right. So one thing that always gets people is the idea of frequency and period. The frequency, right, is the B value. So if you guys see something like y equals 3 cos 2x, something like that, right, this is going to be your B. Okay, it's the number that comes before the x. And we saw today that they didn't have an x, they had a theta at one time, but it's really the number that comes before the variable. All right, frequency is going to be the number of curves, full curves, you see between 0 and 2 pi. They always try to trick you guys with intervals, so make sure we imagine what it would look like if we went all the way to 2 pi. Right? Sometimes they're short, they're only go to pi, sometimes they'll go longer, so we always want to look 0 to 2 pi.
So, like 1 is 0 to 2 pi?
Well, you don't know if it's going to be 1 or not. Right, in a general curve, it will be, but like, you know what, let me give you a picture. So sometimes, like, see how here it's only pi that they show? Okay, they're trying to trick you. So we want to imagine what would this look like if you went out to 2 pi. Okay, so that's where you're looking with 0 to 2 pi. All right, the period is going to be the length of time it takes to see a full cycle. So, the slide before this, we talked about what a full cycle looks like. So just keep in mind that sine full curve starts at 0, goes up, down, and around. Cosine starts at whatever the amplitude is and looks like a horseshoe. So that's what we mean by full curves. Right. And we use this a lot, the period of a trig graph, the formula. Right, you guys have seen that. And it's actually a question on the last one. Right, so sometimes they're really easy. So if we just ask you guys for the period of this function, all we do is take our 2 pi over the b value. Can we know the b? Great. And if we can reduce it, you want to reduce, but you can't, that's it. So it's just choice 4. Sometimes it could get a little bit trickier with what the symbols look like in here. So go ahead and read the next one and see if you guys can think about what's going to happen here. Yeah. You don't want to be So they still ask you for the period of the function. This might confuse you because it says in radian measure. But what do you guys think? What form do you already think it's in? It's already in radian, so that's just why it says it. So if I use 2 pi over b, oh sorry, I should ask you guys this. What is the b value here? Pi over 4. Okay. What are you going to have to do? Good job, Andrew. Copy, change, split. Perfect. So 2 pi times 4 over pi. So what's going to get when you reduce that? 8. Nice job. The pi will cancel, it's just 8. Okay, so sometimes wording may be a little tricky. I just want to match you guys. It's been a long time since we've done this and kind of examined things, just kind of get your brain thinking where they might trick you. Okay, so here they want to know which graph is going to represent from negative pi to positive pi. Anybody remember what happened when you guys saw the negative? Yes, good. The direction changes. Right, so this time we're not going to go up. It's going to go down first. Okay. So now they want to know from negative pi to positive pi. How can you guys see like what's going on in this? Any ideas what we should be using maybe? The graph, yeah, let's put in your calculator. Negative sine x. I mean, we might be able to kind of think about it. Negative sine x. If you guys just came in, we talked about calculators being radians. This is when it's done. Yeah. Okay. All right. And just in case your calculator isn't in it, when you're doing trig graphs, you might want to hit zoom choice 7, where it says zoom trig, just so that way it moves it into more of a radian form. Okay. So on your picture, this is your 0. Does anybody remember what the first interval is? 5/2. Nice. What about this one? 5. Good job. And 2 pi. Awesome. Good job. So in the negative direction, same deal. Yeah. No, you don't have to. It makes it a lot easier. Do you know where they come from? Right? Well, this is your 0. This is 90, 180, 270, and 360. Like from your unit circle. Remember here's like your 0, 360, 90, 180, and 270. So if you forget them, you can always use these and just convert into radian. You know, by multiplying pi over 180? Yeah. But I mean, it's helpful if you know them to come up. Kind of the same thing over and over that you use. Alright, so your picture only wanted though between negative pi and positive pi. Alright, so you can kind of match it up from there. That's good, bad, good? Good? Okay. And hopefully you can kind of tell that it's probably between like 3 or 4. Right? These kind of don't even look like it makes sense. Right. Yeah. Right. There would have to be some kind of a shift if it's not starting at 0. Kind of like the other one that we did. Like this one. How there was a shift because it didn't start at 0, but it was still a sine curve. So it would have to be something like along those lines. There would have had to been like up here like plus something or minus something. Okay, next one's a little tricky too. So they want to know which one could best represent this. So we want to decide, is it a sine curve or cosine curve? Cosine. Cosine, good, because we're not starting at 0. Now, the part that gets tricky, right, we can get rid of those. Now, the b value represents how many full curves you see between 0 and 2 pi. Look at your interval though. See how it's only going to pi? So, imagine, right, if you went to 2 pi, how much of the cosine curves will you see? Is it going to be, will you guys have, oh actually, we could have made this even easier.
What did it go up?
Well, do you see this? Is that going to be a cosine curve? Or does it have to go below the x-axis, right? This thing spread out really, really far. What's your amplitude here? 2, good. Right? If you look, it goes to 2. So we got 2 cos. Now, I mean, we can figure out from this part which answer it is, but when you look at from 0 to 2 pi, how many full cosine curves you see, where you're going to see 2 of them, or you think a half? Half. Good job. Because right now it's only like a little quarter of it, or you have to go all the way up, down, and around. So this would be really big if it's stretched out. Okay. Then just writing some equations. Trig graphs can kind of show up like a lot of different places. So whenever they ask you to write equations, they do. They really like this lately to make you write an equation in the later tests. Make sure you have a y equals. Okay. Decide whether you're sine or cosine, and watch out for the interval, because that's where they're going to get you when you try to get your b values. So make sure you're correct at the interval where you're looking. Right. 0 to 2 pi is always what we want. All right, so for number 1, okay, if you want to write this equation, we need a y equals. Is this going to be a sine or cosine? Cosine, good. All right, what's my amplitude here? 2. But what's good? It's going to be a negative 2 in the front because we're starting down. Good job. So we got negative 2 cos. All right, so the b value, we want to look between 0 and 2 pi. So find the 0, find 2 pi. how many full cosine curves do we see here? 2, yeah. So it should be like 2x in this box. Right, because it goes, here's 1, there's 2. Gotta go up, down, and around. Yeah, I hope so too. Me too. Okay. Alright. What do you guys think for this one? Alright, I like the y equals, and then you said what's the amplitude? 2 sine. Right. Oh, I love this part. Okay, this is the tricky stuff. Right. 0 to 2 pi, right? There's only how much of the curve do you see? Half of it. Yup. Good job. So it's half x. Imagine to be a full curve, it has to keep going.
These are the only people you have in this class for review.
Yeah.
The Regents.
Yeah. I have a whole team. I'm not even.
What class is it? Was it the class I used to be in?
Yeah.
This is like the most stressful freaking session ever taking your entire life.
I know. All right. Take a second. See if you guys can pick which one you think this is going to be. Okay. This is a little tricky because it's got some stuff going on here.
And this is June 19th, so it's in 19 days.
Yeah.
That's good.
Right, but that's not
Yeah, but like
You try.
you try.
I tried the last 2 times. James, your assholes. You know?
You have a trig background, but Nancy's kid too.
Alright, so what do you guys think? It's telling you that it's got to be a sine curve. What's the amplitude going to be in here? 1, nice job. There's only 1 when you cut it through the middle, so it can't be 4, it can't be 1. This is where trickiness happens. What is how much are you moved up? 2 units up, so at the end we need a +2 because it's taken and it's moved 2 spots up. So we have a shift of 2. And if you look between, let's see, 0 and 2 pi, what do you guys see between 0 and 2 pi? Here's 1. Actually, wait a minute, there's a mistake in here, isn't it?
Yeah. Why did it be like 1?
This can't be it. Yeah, this is wrong with all these multiple choice. Let's write our own equation. Okay, so what's the amplitude? 1. Okay, so now when we look at 0 to 2 pi, imagine you went all the way up to 2 pi. How many sine curves did you guys see? Well, this right here is 1. All right, that's going to pi. So if you doubled it and went to 2 pi, we would see 2 full curves. All right. Now, how much were you guys raised up? +2. Okay, so that.
Was that a reason question?
No, I got this off of JMath. So
Do you think they meant the 4 to 1?
maybe, but this shouldn't be 2. It should only be 1. Yeah, it's like the closest one. So.
Do you need to put a one side in front of it?
No, you don't need to put the 1 in front. Okay. This one's off for Regents. I thought this was a really tough question. Sorry. Okay. So I thought this was like kind of one of the hardest ones you guys would ever see. Right, really tough.
This is so stupid.
Well, you gotta be ready for it.
Well, there's so many stupid questions.
Well, you might get stupid questions.
Before. Yeah. Oh, you're fine. Noel texted the group and was like, I called shotgun, and I was like, too bad I'm not close here.
Alright, so this is kind of nice. We tell you guys you have an equation. Alright, you've got your y equals. For the A, this is tough. Now imagine a rope. If you guys are like swinging a jump rope, it's going to make a little wave, right? Okay. Now the range means it's going to go from what to what? 1 to 5. So it's going to go up to 5 and then down to 1. What can we do to find our amplitude?
Bless you. Close. Well, look at the picture. You thought it was 3? The 3 matters with something in here. But not
It's a plus 3.
good. It's a plus. Nice, Anthony.
Okay, good. I like that part. This part here, the plus at the end means how much it shifted up.
Would it be 4 or something? Because it's 1 to 5.
Well, okay, so imagine you're shifted up 3. Okay, so here's 3. You went up to 5 and down to 1. What's the difference in there? I don't know. 2. Good. Right? 5 minus 3? That'd be 2. So this is going to be a 2 sine. Now the top part is the b. They give you a clue in here what to do.
4 pi.
4 pi, right? So
Pi x.
2 pi over b has to equal 4 pi. Right? That's what we know, that the period, which is 2 pi over b, has to be 4 pi. So what does b have to be for this to work? Well, how can we figure this out? Cross multiply. Good, so we could have 2 pi equals 4 pi b, b 4 pi, I don't care what you guys do. Right, multiplication we do. Nice, yeah? Okay. Alright, so what happens to the pi? Go away, yep, and then 2 over 4 is really 1/2. So this part has to be 1/2 x. Right, that's how hard it could be. Pretty tough. She might already be in there. Okay. Alright, the last thing is just real quick and easy, and we did it today in class too with one of your questions. Just making sure we know how to graph things, you know, match them up. So if you were going to graph tan or cotan, okay, let's just quick type them in and make sure we know how to do this. So tangent would just be tan. So make sure you put an X in. Oh, yeah. Okay. There's something special with tangent and same thing with cotangent if you guys graph them. Does anybody remember what's happening or what these things are called that happen here? It starts with an A. It kind of sounds like a bad word.
Asymptote.
Asymptote. Good job. Very nice. Okay. So it sounds like asymptote. Oh God, Anthony. All right. So this is a place where it can't happen.
Miss Dash is over there, but Miss Dash not over there, so it's always the same C and this really bad.
Yeah, so this is it's like a Google training thing, you know. All right. So these are places where your graphs can't happen, right? Where they would be undefined. So your calculators don't show the asymptotes unless you have like an 83. It might show the line. If not, like this. So at like, if you guys just had pi over 2, it is pi over 2. Do you guys have a value there? Is it defined or is it undefined? Undefined. Good, because it can't happen here. It doesn't touch anywhere. That's on an asymptote, so it can't work there. Okay. If you guys are matching pictures to graphs, I think we had one like this kind of too recently. Okay. If I gave you guys this picture and I asked you, which equation is it? Use your calculator. If you try to type in cotan, right? Do we have a cotan button?
No.
No. Well, good. Wait. Cotan, you could do 1 over tan. All right. What else could you have done? Cosine over sine. Okay, 1 over tan is easier, so let's do that. Oh my gosh, X, there we go. Right, so if you guys type that in, is that going to be your picture? No. Okay, so we know it's not that one. All right, let's try cosecant. Right, we have to type in though 1 over the sine to do it. Okay, so let's type this thing in. See, it looks kind of like it, but look at your axis. That's always how you guys are going to try to find things. So if we look at the axis, is that one going to be it? No, right? You need one that crosses. All right, 1 over the cosine. Let's try that one for the secant.
Just a reminder, the Google training is now starting in the high school computer lab.
Okay, so we try this one. What do you think? Yeah, right? You can look and see the section right here. Okay, this is kind of what they were talking about. Okay, let me just show that one part. Yep, just show just this part. Right, just always look to see where it crosses. And that'll kind of help you guys that it hit this part right in here. Are those good for you? Yeah? Alright. Sorry, I have 2 more real quick. So I can scooch in there. Okay, so cos negative 1x. Do you guys remember how to get that? Arc, yeah. Second cos. Nice. It's like the arc cos. Right, the inverse. So we did second cos. Right, we graph it. Okay. We get this little picture, and we talked about this today because I think it came up in one of your questions, that really, this is the reflection over the line y equals x with the cosine curve. It keeps going and going. But your calculator stops it where it has to be a function, where it would pass the vertical line test. So you only see this little picture. Right? And you want to make sure you understand where it would cross the axis. That's really what you want to focus on. It would cross the x-axis on the positive side, right? Not over here, it didn't cross through 0. Okay. Do you remember this kind of question? Matching things up. The one that's going to be tough if they give it to you, right? It's been coming up on a lot of the later Regents exams, is stuff like this, right? Using domain and range.
Will they tell us to do that?
No. Well, like this, I mean.
They won't tell us how to do like the material, right? This kind of
No, it'll be a picture. Alright, they want to know which one of these is true. What is the domain? Is that x or y? X. Good. Ranges y. Okay. So keep in mind that, you know, what you're looking at here. Okay, so if we did arc sine, let's see what we know about that.
Why does it all matter?
Because it doesn't happen there. Remember how it can't be a function, like it can't go beyond certain things? Okay, so let's see. Second sine. Okay. Alright. Now you want to use your table for these. So if you use your second graph and you pull up your table, look to see what they're asking you guys about. They want to know with the domain. So on the x, we want 0 to 2 pi. Okay. So your x part, okay, we have 0 through. Is it 0 to 2 pi or is it 0 to negative 1? 0 to negative 1. Yeah, that's not going to work. Okay. The second thing they ask us, so it can't be that, they want to know is the range between negative 1 and positive 1. Well, let's look at the calculator again. My range is the y, so is that negative 1 to positive 1? This is? Negative 1 to positive 1? No. Okay, so it's 0 to negative 1. Alright, this one can't work. So let's try the arc cosine and see if any of those make sense.
Wait, why can't it? Negative 1 to 1?
Yeah, but look in here.
Oh.
Oh wait, hang on a second. Sorry, you're right. Well, it's not right though, but is that negative 1 to 1?
Oh no, because it goes over.
It goes over. Right. It's not like negative 1 to 1 exactly, it's like a little beyond. So let's keep going though. Maybe if you guys had a guess at the end of one it match up, but let's kind of see. Alright, so our cos, second cos, graph that thing. Now let's use our table. Okay, let's check this one out. Okay, Now, one thing that's going to be kind of tricky here. This is where our function's going to be happening. Domain is negative infinity to positive infinity. Well, it can't happen over here. So is it going to be between negative infinity and positive infinity? No. Alright. The range is 0 to pi. This is how they like to show things, okay? But you have to be on the lookout for it. We have 0. What is 3.14? Pi. Okay? So they'll write it, but it has to be decimal. Okay? So if you guys see decimal, see, is that what pi over 2 is? Is that really what pi is? Right, so 0 to pi is like what works in this one. That would be pretty small. Use your calculator. Alright, good job.